Well, today's focus story is seasons, and we'll take a look at what causes the seasons. First, picture the Earth as being out in space, rotating or revolving around the sun. And this is what it does. It goes in this direction. In fact, really all the matter in the universe, or at least in this galaxy of ours, goes this way, kind of around a center of the universe, or a center of the galaxy again. And the Earth goes this way around the sun. The sun even rotates. The Earth rotates around its axis, so that's the way we're turning around right now. Now, winter came just about a week or so ago, December 21st and 22nd, the Earth revolving around on its axis, and the axis pointing toward the North Star. The North Polar axis pointing toward the North Star all the time in all of these pictures. So it's like a gyroscope going round and round. And when the sun hits the Earth on December 21st, 22nd, it shines more intensely on the southern hemisphere than on the northern hemisphere. In fact, the Arctic areas never even get the sun on that day. Now, by the vernal equinox, March 21st and 22nd, the north and south poles are just barely illuminated by the sun, and the equator has the sun right overhead. So everybody gets 12 hours of daylight, 12 hours of darkness, whereas the southern hemisphere gets the longest days here. And then by the summer solstice, the northern hemisphere gets the longer days, and the northern Arctic regions are in the sun all the time, whereas they never get the sun down in the Antarctic regions. Come around to the autumnal equinox, late in September, well, one side of the Earth being dark, but again, North Pole and South Pole just getting the low horizontal angle of the sun, and the equator gets the full tilt with equal day and night. That's equinox. Equal day, equal night, 12 hours each. So in the summer, the equator is actually south of the direct rays of the sun. The sun's direct rays hitting the Tropic of Cancer, continuous daylight in the Arctic, and higher sun angles and longer days in the north, lower sun angles and shorter days in the south. In fact, we even have a seasonal lag. Even though we have the longest day of the year on June 21st, the strongest sun's rays, the highest sun's rays, the average temperature actually gets the highest in late July. That's called a seasonal lag, a little later than the best sun. The winter solstice, the equator tilted this way, the sun's direct rays hit the Tropic of Capricorn, and the more, say, acute rays hit the northern hemisphere, so we have low sun angles, and the North Pole is faced away from the sun and never even gets any sun.
There are other seasons to